Well, everyone able to hear me just fine? Excellent, excellent. One of the things that we've found at GSK and has been a problem, and I imagine is a problem in a number of companies, is that you start off with a lot of little toolkits that you acquire over the eons, and eventually at some point you need to make them talk well with each other. And what we've done at GSK is we have bought into SOA, or service-oriented architecture, in order to do that. I'm not sure why I've got this up here, but we'll make that go away. Excellent. Got it. No worries. So what we'll talk about today is the history of the service-oriented architecture at GSK, how we got there. We actually, our work in that area actually predates the term, where we are today. And then I'm going to go into a few case studies where we look at particular solutions that we put in place for property calculation, structure search, and structure format translation. Each of them brought on their own set of issues having to do with hardware and platform, structure representation, and of course some of the problems that we faced with the formatting for, say, substructure search. And then once you get your results back via a web service, you have to consider things like how do you deal with big data sets, and how do you cross databases, that kind of stuff. We'll also talk about how we work with mixed database technology, where you are working with a number of different cartridges, and what we plan on doing next at GSK. So it starts at our last big merger with SmithKline Beecham and Glaxo Wellcome. And what we found was that both companies brought their own tools to the table, and their own databases, and their own technologies. And we said we could spend a lot of time trying to put these into one repository, or we could make some attempts to future-proof it by putting a layer on top of that. And that layer we did in around 2000 was to put something, I guess, later became known as web services. At the time was simply something a lot cruder than that, but it was essentially XML over HTTP. Our first foray into that was a service called Chemistry Information Service. Not exactly an original name, but it started out with the capabilities of searching for identifiers from the two different companies. We had two different identifier schemes. Users didn't want to deal with figuring out how to get it from one or the other, so they wanted to be able to put in an identifier, and it would search both of the corporate databases, both the corporate sources. Over time, this Chemistry Information Service became a way of doing structure search. Then later on, we added the ability to convert formats of structures. And it grew into quite a few methods and grew into quite a bit of use. The first one got long in the tooth, and we eventually went with CIS2, which actually brought it into formalized SOAP. The first one, I think I mentioned that in the next slide, was just custom XML over HTTP, and it was before there was a formal SOAP standard, any of that stuff. We also vastly improved the performance on CIS2. As a matter of fact, CIS2, despite the fact that it's been deprecated for use, is still heavily used today, much to our chagrin. But at its peak, it provided up to 500,000 ID conversions per day, and an ID conversion is simply an ID lookup into one of the corporate databases. Started off as C++, then later on moved on to the Java web services stack. As I had mentioned, it's served us well, actually, over 10 years, or almost 10 years. We had a number of clients. The amusingly named ChemFido was one of the first, worked with CIS1, then later became ChemRetriever, and only just this year did we retire that one. We also had an SAR spreadsheet tool called Chemically Aware Spreadsheet that uses all of the current iteration of CIS, CIS3, uses all of that in this desktop application. So we've seen a lot of benefits from it over the time. One of the benefits was, as I'd mentioned, these incompatible databases. And I don't know how many people here remember or are familiar with Thor. Thor is one of the original databases we were using for Registry at the time of the merger. And we had another version of the Registry from our other source as MDL ISIS host database. It was on VMS and Unix. And we just used this such that it would be on top of both of those data sources, and it would allow the users to not have to think about where it's coming from, how it gets there. We also had structure normalization rules that were different at the different companies. That leads to religious wars, and what you can do is eventually, once that gets settled, you settle it on the SOA. You settle it in one place. You don't deal with it anywhere else. You can therefore, swap underneath the hood, but you settle it at that layer, and anyone who consumes those web services would get the official normalization scheme. And as I'd mentioned, because my background is actually, I developed a number of the clients that use these services, so I've experienced the growing pains of trying to adapt it to a number of technologies, whether it be in .NET or in Java or even straight to Perl, or just I've had some experience from that side. So I've seen how we have evolved from XML over HTTP to formal SOAP, formal XML with namespaces and all that. That has definitely helped from a developer side of things. But it has also helped other clients of the tools in that they don't have to go through these growing pains now. I think I'd already mentioned some of this stuff about the SOAP compliance. A lot of the stuff that when we move to one version to another, even if we were shuffling things in the background and retiring services or retiring background databases, users didn't need to even know about it. It just happened quietly because the clients they were using were going against the service rather than against the underlying database. And then once we saw the success of this chemistry information service, we decided to expand that foray into other areas. One was the property information service. Started soon thereafter, but we used that to be a collection point for a number of different property calculation toolkits. And basically, it provided, again, a unifying interface such that you don't need to know underneath the hood whether the vendor is ACD, Biobyte, Daylight, ChemAxon. Basically, any of those can live underneath the hood of a property information service that provides that common interface. We learned some things from that one as well, like what do you do when, for the most part, calculating a property like molecular weight is pretty easy, and you know how the result's going to come back. It's going to come back in a pretty small field. But when you are working with something like ClogP or CMR, it comes back with both a value and an error code, and that we didn't handle well. But we're getting better. And even though this one is also slated for a refresh, we've got, I think we're on our third iteration of that as well. Many users are still using the first and second versions of that one. So some of the things we've learned with using SOA at GSK, that's a lot of three-letter acronyms, is that keep them simple. Keep web services simple. Don't try to make them do too complex a response. That's what worked for us at first when we do an ID to structure search. The idea was you want to just put in an identifier, one or many, and get back that result set. You don't want to have a very complex object that you're setting in. One of the other things that one of the other lessons learned was the reliability of smarts. Now, I know that we've had a number of talks about that now. At the time, we had a smarts tool, or actually a mole to smarts tool that we developed in-house that was written in Fortran. Ouch. Ouch. And we maintained it, and frankly, I'm glad we're not in that business anymore. There are much, much better tools for doing that on the market than the one that we had in place, not least of which is ChemAxon's. But rendering smarts is still an issue today. I mean, actually being able to draw out a smarts is something that is not always intuitive. Another lesson that we learned was that granularity of the services. See if I can explain this. The idea is you're not wanting to do a service that's going to get you something from at the atom or bond level. You're not going to also want to come back with a very complex object. It just doesn't lend itself to that because you're spending a lot of time sending a lot of data across the wire via XML. You want to keep it at a happy medium. And what we found that was structures were about the right size. I think I've already hinted at this, that web services can easily be oversold. You hear about SOA, and it's the wave of the future. Well, be careful with that because, again, there are complexities with it such that you don't want to try and use that for your solution for everything. Complex input and iterative workflows, we found it didn't lend itself to it. It just wasn't fast enough. Library enumeration, tricky business, again, complex. It's just the input became too complex, let alone what you get back out. And I'm not going to speak to others except this last one, HGS data. What we found was that the results that came back from that, the server could certainly send back as much data as you wanted to consume, but the client would blow up from HGS data that came back. So you want to make it such that not only can the server provide what you need, but the client can actually consume it. All right, so this is where we are today. We have a lot of web services in-house, but underneath the hood, we've got a lot of vendor technologies. And since we have dedicated ourselves to using SOA, we've had to really, really beef up the servers that perform those operations for us. So we've had to make sure that they're load balanced, that they're behind an F5, behind F5 hardware. And we've also moved towards what's called the service-oriented architecture registry, or SOAR. It's IBM's solution for allowing these services to be discoverable. You go to a site, it's sort of like UDDI, where you can query for services that you might need for your particular business needs. So you can go there and say, I want to have any service that has to do with finding substructure. You put that in there, and the term would come back with the services that pertain to that. And because we've done it this way, we've been able to serve a lot of different clients. As there's a few mentioned here, some are thick clients and thin clients, workflow and scripting clients. So it allows us to integrate with a lot of different languages and a lot of different clients because we've done it that way. And this gives you some ideas of how heavily they're used. These numbers actually don't look all that large, but when you consider that chemistry lookup can be anywhere between one identifier and tens of thousands of identifiers, that hit is one hit for each of those kind of searches. So that one hit could have been for 100 identifiers. It could have been for 10,000 identifiers. It's used 8,000 times a day. Structure search is also used. It's used less than some of the others, but of course, structure format translation is used quite a bit. And simple property calculation is another one that's heavily used. And just for historical reasons, we still have CIS2 deprecated, used 5,000 times a day. That's worldwide. That's worldwide. So these services are actually based in UK. So I'm going to just briefly go through, just mention some of the lessons learned from these three here, because I don't have all that much time that's in the included slide pack. But we had three different services. We had the structure conversion, where we had problems that we solved with SOA, such as how to deal with multiple vendor algorithms, and in particular, also how to cover multiple service calls. For example, we saw you mentioned the chime to smiles transition is not a straightforward one, because oftentimes you have to use the custom tool from NBL. What we've done is, underneath the hood, made it such that you can do a chime to smiles transition without having to go convert to mole file, convert from mole file to smiles. That can be hidden under the hood as well. Yes?
What do you use to go from mole file to smiles? Like what kind of smiles do you use?
Actually, it depends on the database. Now you're talking about for just a conversion.
Yesterday I saw a wonderful new tool.
Yeah. I'm not at liberty to say what tool we're using at present, but suffice it to say, there are some excellent tools out there for doing that. Again, we've seen one here that does that very well. We have in the past used, as I said, our internal one. We have used Daylights. We have used ChemAxons. We've evaluated all of those. Let's see. I'm not going to. I've already covered the multi-step conversions and how we resolve that. This is sort of an architecture of how we've kind of hidden that behind the service, where it allows us to go to different vendors. One thing I do want to cover, and let me skip through these things here, is the benefits that we've gotten from this. And this is actually the take-home message for all the other services as well. So I won't go to the other services and talk about them, but I will talk about the lessons learned from this structure format translation. Is it allows us to be both backward compatible and upgradable. Specifically, again, we've got the conversion algorithms can get upgraded under the hood. The vendors can be swapped under the hood without notifying the users or requiring a client change. However, you can maintain vendor continuity if that's necessary. In particular, for property calculation, there might be a particular algorithm you need, in which case the client of this can specify a particular vendor. So you may have a preferred vendor and have that change, or you can say, no, I really need it to be Daylight, or I really need it to be MDL, or I really need it to be ChemAxon. You can do that. But there is a default, a preferred one, and that can be changed at any time. And we can add these conversions as plugins that are detected at startup. So that allows us to add any number of them. And this is just a little side note that we can handle these multi-step conversions and also handle the errors cleanly. I think I'll probably stop it at that point rather than going forward with the other services. These are some of the take-home messages from SOA at GSK and how we benefited from it. So I appreciate your time.